In this video, I want to review how light interacts with objects. To begin, we use light and dark in two-dimensional work to show volume and structure because it is a near universal language. This is because as light leaves its source, it acts in a pretty predictable way that we've all experienced. So let's look at how light interacts with objects. So right out of camera, I have a clamp light. That clamp light is a spotlight that is producing a pretty warm light. And as that light leaves that source, it moves through the atmosphere, hitting everything in its path. As the form turns away from that light, that form turns into darkness. As that light moves through the atmosphere, it gets dimmer and dimmer and dimmer. So I like to call the way light becomes dimmer and dimmer as it moves through the atmosphere, hierarchy of light. So as light leaves its source and hits this sphere, the part that is facing the light is receiving the brightest light. We call that the highlight. Now as that form turns, in this case, because it's a sphere, it turns in every direction and it makes a smooth, gradual shift as opposed to an abrupt planar change. It gets a slight gradation, but at some point it fully turns from the light. This moment right here is called the shadow core. This shadow core is the darkest part of darkest value on the actual object. Now, as you notice, and you can kind of look, there is a moment where we go from highlight and a slight gradation to shadow core. But as you look at this, I want you to notice how the darkest part of the shadow core is closest to the light. So we get highlight, shadow core. That edge of the shadow core is darker here. So it makes a slight gradation, then jumps in value. Now the form continues to turn, and this form is not in a vacuum. It is in a world with other surfaces that are bouncing light back. So as the form continues to turn, we get what's called the reflective light. And this would be that reflective light right here. Now, reflective light is a vital element to include in your work. Very often we see the highlight, we see the shadow core, it's really clear. The reflective light is how the viewer and yourself as you move around the world judge how that objects are in proximity to each other. In other words, the way an object looks like it's not just floating in outer space or in a vacuum is by the fact that there's the presence of reflective light. So we have highlight, shadow core, reflective light, and then we have our cast shadow. I'm going to take this off here so we can see our cast shadow a little clearer. All right, let's look at our cast shadow. The cast shadow has a direct shape in relationship to the light. So the closer it is, the more direct it's under the light, the closer the shadow is to the object. The further it gets from the light, the more oblique that angle gets, and so the larger the shadow gets. Let's bring it back here to the middle so we can see it. Now the cast shadow is made by the absence of light, or the fact that the object is blocking the light. Right close to the object, the cast shadow's edge is strongest because it's really getting a lot of fall off. As that shadow gets further and further away from the object, it gets more kind of interference and reflective light, and that edge becomes blurrier. So this edge, this from here to here, is not a universal sharpness. It goes from being a harder edge to a blurrier edge. Now, how sharp and how blurry this is affected by the strength of the light. The stronger the light, the sharper this will be, and even a strong light will have blur at some point. And the more diffuse a light is, the less its shadow will be. Now you can see that a cast shadow is not a pit of darkness that no light can escape from, but that there's a lot of different types of light in here. And as we'll look closer when we add color, but you can see, even I think in this video, a lot of reflective light bouncing on to this bottom right here. So we have highlight, shadow core, reflective light, cast shadow, and within that cast shadow, we have a shifting edge and reflective light close to the object. That's light bouncing off this object in here. Here I have set up 3 groupings of objects with different proximities to the light source. This sphere and block are very close to the light source and receiving the most light. The cylinder and second box are further. And so while they are receiving light, while they do have areas of highlight, shadow core, reflective light, and cast shadow, respectively, they're not as intense as the sphere and box that are close to the light source. As you notice, the objects that are closer to the light source, not only are their highlights a lighter value, but their shadow cores are darker as well, higher contrast. If you come over to this cylinder here, which is receiving that same type of light, it has a highlight, it has a shadow core, it has reflective light, it has a cast shadow, but its highlight, shadow core, and reflective light are all have less contrast. So while it has all of the same light patterns and same patterns of light, there are less contrast. This is because this object is further away from the light. And not only is its highlights brighter when they're closer to the light, but the shadows are darker and higher contrast.